Hey everybody, so today we're going to be talking about square roots. The good news is that this is something that you've already seen before. When you're going through these notes, you should have out your blue perfects card. Okay, so when we get going here, we should all know what the radical sign is. Wrong pen. It's the square root symbol. That's the radical sign. And in this unit, it's only going to mean the positive square root. So what that means is, for this unit, you do not need plus minus in front of the square root. That's nice because a lot of times it's like a half point on a test and a bunch of people forget it. So we're talking about square roots. The square root of n equals r if r squared equals n. All that is a fancy way of saying, for example, the square root of 36 is 6. So that means that 6 squared is 36. 6 and 36 are related to each other. In this example, n, the thing that's underneath the square root, is called the radicand. Okay, so properties of square roots, you need to know these. They make sense. You've seen them before, like I said before, but you need to know how to apply these. For example, if I have the square root of 50, I can't take the square root of 50 and make it come out nice. So what we want to do is reduce these. So what we do is we look at our perfects card and we say, okay, what's the highest perfect square that multiplies into 50? You should know that 25 is a perfect square, and 25 times 2 is the square root of 50. So the product property says I can break apart that perfect square, 50, into 25 times 2. Now we know that the square root of 25 is 5, and we can't reduce the square root of 2, so this reduces to the square root of 5 times the square root of 2. Also, notice how I put the perfect square first. I would get in the habit of that. Now, this is technically also correct. You could put the square root of 2 times the square root of 25 and then say the square root of 2 times 5, but then you just got to take an extra step and write it as 5 times the square root of 2. Just like multiplying, the product property, we have the quotient property where we can divide square roots. So all it's saying is that if I have a fraction underneath the square root, I can pull it apart and make two separate square roots with it. So for example, if I have the square root of 9 over 16, I can reduce that to the square root of 9 over the square root of 16. And then hopefully you have these two memorized. You should know that the square root of 9 is 3 and the square root of 16 is 4. So that reduces to 3 over 4. Okay, now moving along. Our first example is just reducing one square root. And again, when you're doing this, you want to look at your perfect square card and ask yourself, okay, what is the highest perfect square that multiplies into 75? Examples of perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So out of those numbers, 25 is the highest perfect square that multiplies into 75. So 25 times 3 is 75. So this would reduce down to, well, the square root of 25 is 5 times the square root of 3. Okay, so now in number 2, we are multiplying two separate radicals. Now, the thing that's different here is in number 2, the first term, 3 square roots of 5, has something on the outside of the radical and something on the inside. I call it outside the house and inside the house. Now, when you are doing this, you can multiply things that are underneath the square root by things that are underneath the square root, and things that are outside the square root by things that are outside the square root. So, for example, you could have 3 square roots of 2 times, we'll say, 6 square roots of 5. You can do 3 times 6 is 18, and 2 times 5 is 10, so this would be 18 times the square root of 10. That is perfectly okay. Things that are outside the house, 3 and 6 are outside the radical, 2 and 5 are inside, and you can combine those like terms. So when you have a problem like this, the first thing I want you to do is make sure that each radical is simplified. So the one on the left, 3 square roots of 5, they simplified that for us already. We do not need to do anything with it. But now we need to ask ourselves, okay, on 12, do any perfect squares? Perfect squares, again, are over here. Do any of those perfect squares multiply into 12? You should say, well, yeah. Oh, boy. You should say 12 is the square root of 4 times the square root of 3. And now you can ask yourself, well, the square root of 4 is 2. So now you have 3 square roots of 5 times 2 square roots of 3. And now you multiply things that are outside the house. 3 and 2. And 3 times 2 is 6. And you're going to multiply things that are inside the house. 5 and 3. 5 times 3 is 15. So we should get 6 times the square root of 15 for that answer. Okay, now on to number 3. Well, 5 square roots of 2, no perfect squares go into 2, so that one is done. So we have 5 square roots of 2 times 6 square roots of 8. Well, now the problem is we need to reduce 8. So do any perfect squares go into 8? Yes, this is 6 times the square root of 4. 4 is a perfect square, times the square root of 2. So now we have 5 times the square root of 2 times 6, and we can reduce the square root of 4 down to what? 2 times the square root of 2. Now we just multiply together everything that's outside of the house. So what is 5 times 6 times 2? Well, 5 times 6 is 30. 30 times 2, you should get 60 times the square root of 2 times the square root of 2 is the square root of 4. But now we got to look again. Can we reduce the square root of 4? Well, yes, the square root of 4 is 2. So now we have 60 times 2, which is 120, should be your final answer for that one. Okay, those were all the product property. Product, again, is multiplying. Let's move on to the quotient property. So the quotient property states that we can split apart this radical. So this is the square root of 4 over the square root of 25. And if you look at your perfects card, you should see that, well, the square root of 4 is 2. The square root of 25 is 5. 2 over 5, final answer. Same concept for number 5, but now we're going to take it a step further. So we're going to break this apart to the square root of 50 over the square root of 9. Looking at your perfects card, you should see on the bottom we have a nice one. The square root of 9 is 3. But on the top, we need to reduce the square root of 50. So what perfect squares go into 50? Well, that's the square root of 25 times the square root of 2. And you should know that the square root of 25 is 5 times the square root of 2 over 3. Okay, one thing I want to talk about here is, this is kind of a side note. Now, let's say we have a problem like that, and we reduce it down, and we reduce and reduce, and we get it down to 6 square roots of 3 over 3. Now, when you see those numbers, you should think, oh, I can reduce this. However, we can only reduce things that are outside the house with things that are outside the house. So 6 and 3 are both outside the house. So we can reduce 6 over 3 to be 2, but that square root of 3 we can't reduce. It would stick as the square root of 3. Okay, last one here on the quotient property. This little box, it means you can't have a radical, a square root, in the denominator. Now, if you plug that into a calculator, if you plugged in the square root of 3 over the square root of 5 into a calculator, it would spit out an answer. However, that is what I like to call Sparta math. I'll explain that more in person, but it's bad math grammar. We can't have it. So what we need to do is something called rationalize the denominator. And all that means is you take whatever on the bottom inside of the radical. So what's inside the radical on the bottom? Well, 5. So we're going to multiply the bottom by the square root of 5. Then we need to do the same thing on top. Multiply by the square root of 5. If we do something to the bottom, we have to do the same thing to the top. Think of it like an equation. If you add 3 to the left, you got to add 3 to the right. Same concept, but we got to do it to the top and bottom. So now on bottom, the square root of 5 times the square root of 5 is the square root of 25. And now what is the square root of 25? Oh, well, that reduces down to 5. And now the square root's gone. That's why we do it. Now on top, we need to do the square root of 3 times the square root of 5. The square root of 3 times the square root of 5 is the square root of 15. And now we have the square root of 15 over 5. And again, like I just talked about, we can't reduce those because 15 is inside of the house and 5 is outside. So it's the square root of 15 over 5, final answer. So yes, it is okay to have a radical on top, but it is not okay to have one on bottom. Okay, just a few more here. Okay, next up we have solving quadratic equations using radicals. So, in other words, what we're going to do now is get x alone. Get x alone. Now, I know in the beginning I said that we don't need plus minus. That's when we're doing radical equations. When we are solving, we need a plus minus. So, right away, we need to get x alone here. So, what's the first step? Add 2. Add 2. 4x squared equals 100. Now, the next step is to divide by 4. Divide by 4. We now have x squared equals 25. Now we need to get rid of a square. And how do we get rid of a square? Well, we take the square root of both sides, square root, square root. The square root of x squared, all that does is get rid of the square. We now have x equals, the square root of 25 is 5, but it could be positive or negative. Plus or minus 25, final answer. Okay, moving on to number 2. Now, this one is goofy. Why? Well, that fraction out front, we hate fractions. So what we're going to do is, another way to write this would just be x minus 4 squared over 5 equals 6. So if we're dividing by 5, how do you get rid of dividing by 5? Well, multiply by 5, multiply by 5. You're then left with x minus 4 squared equals 6 times 5 is 30. Okay, now the next step is to get rid of the square. I need to get rid of the square because the 4 is in the parenthesis with the x. So to get rid of the square, again, we're going to take the square root. We now have x minus 4 x minus 4 equals the square root of 30. And again, it is plus minus. So the last step to get x by itself is just plus 4. Now the goofy part is, okay, where do I put that plus 4? You're going to put it out front. So you're going to write it as x equals 4. I'm going to stick it out front right there. Plus or minus the square root of 30. And now the nice thing is, if you don't know what this is, if you don't know what the square root of 30 is, in other words, if it doesn't come out nice, just leave it like that. Otherwise, you're going to get 2 messy decimals. Just leave it. Okay, next one. Again, our goal, if we are solving a quadratic by using radicals, we want to get x by itself. So the first step here is to get x by itself. Minus 3, cancel. Negative 7, x squared equals negative 1 minus 3 is negative 4. Okay, our next job is to divide by negative 7, divide by negative 7, cancel. X squared equals a negative divided by a negative is a positive 4 over 7. Now, again, how do we get rid of a square? We do square root. So we write this as x equals, now you know you can write it like this, the square root of 4 over 7, but I encourage you to just skip that step and write it as the square root of 4 over the square root of 7, because you know you're going to have to do that eventually anyways. Now, we can reduce the top to be 2 over the square root of 7, but now we got Sparta math. We can't have a square root on the bottom. So what we need to do is that thing called rationalizing the denominator. And again, to rationalize the denominator, you need to multiply by the square root of 7. You need to multiply the square root of 7. Now, on bottom, we're going to get the square root of 49. On top, since 2 is outside the house and 7 is inside the house, we cannot combine them. So it's just 2 times the square root of 7. Now we got to look, can we reduce the square root of 49? Well, yeah, it just goes to 2 square roots of 7 over 7. Now, 7 on top is inside, 7 on bottom is outside, so you cannot combine them. So you should get x equals 2, plus or minus 2 square roots of 7. Okay, last one. Again, solving by using radicals, we need to get the variable, in this case m, by itself. First step, minus 10, 6 times parentheses m plus 7 squared equals, equals 54. Next step, divide by 6, cancel. M plus 7, parentheses squared, equals 54 divided by 6 is 9. Now again, since the 7 is in the parentheses with the m, we need to get rid of the square. To do that, we're going to take the square root. We're going to take the square root. Should now have m plus 7 equals, the square root of 9 is plus or minus 3. Now, the last step here is to simply minus 7, cancel. Now I have m equals, and I told you before, let's put this negative 7 out front. So let's write it as negative 7 plus or minus 3. But now, unlike this problem before, where we had a radical and it wasn't nice, we didn't know what it was. Oh, that arrow sucks. Anyways, it wasn't a nice square root. Now we have a nice square root. So we can actually finish this off. We can say, well, negative 7 plus 3 is negative 4. And we can say that negative 7 minus 3, well, that's negative 10. So your two answers are m equals negative 10 or m equals negative 4. Okay, after you have filled out your note sheet, please go show your note sheet to the sub. He will then give you your assignment. That assignment is due Monday. I will type everything out on Google Classroom that is due as well, so that there's no confusion. Other than that, hope you have a great weekend, and I will see you on Monday.